Hey everyone. Better. I'm super excited to be here and to talk about my favorite subject in the world, which is computer terminals. A few years ago, I started a project called Zellij. Zellij is a terminal workspace and multiplexer. You can do all the normal things that you can do inside a terminal in Zellij. Inside a Rust project, I can run the cargo tests and wait for their output, for their compilation. Or if I don't want to wait, I can send them to the background inside a floating pane, see them kind of going on there, make the pane bigger, smaller, place it in the background, and continue working. I can...
The camera cannot capture.
Aha.
Can you put this?
Let's see. I can open multiple panes. I can rearrange them. In these panes, I can do whatever I want. Zellij has stacked panes, so I can kind of page through panes like this. I can bring back the command, and if I don't want to wait for the compilation, I can stop it. Since this is a command that Zellij runs on its own, then I kind of get the exit status in the UI. Here, because I did Control-C, that's just exited. No exit status. I can press Enter to rerun it, Escape to drop to shell, or Control-C to close the pane completely. Zellij also has plugins. So if I go into a certain folder, let's see, I'm here, and I want to search for a specific Rust struct definition. So I'm going to invoke Monocle. Monocle is a Rust plugin compiled to WebAssembly running inside the Zellij runtime. It gives me a fuzzy find for the file names and their contents. So if I'm searching for struct pty, it leads me to the correct file and the correct line. I can page through the results to get less and less relevant results, or I can press Enter, and Monocle will open the file for me in my default editor. In my case, it's Vim. To the correct line, I can edit it, do all the things, and like leave Monocle, go back to Zellij. We're going to talk a lot more about Rust plugins and generally the Zellij WebAssembly Plugin System. But first, I want to talk a little bit about terminals and how terminals work so that we can understand the ecosystem that we're writing for a little better, know all the players, and know like how to take advantage of it. After that, I'm going to talk about Zellij, its different features, how we can use them, and then we'll get into the WebAssembly plugin system. I'll talk about like how it works and look at a few plugin examples so that we get inspiration. Personally, I am a terminal developer. I develop all my code inside the terminal. I use Vim to write the code, to edit it. I use Zellij to open different panes and interact with my operating system. But this tool and this talk is not just for people like me. I think most, if not all, developers use the terminal. Even if we write code inside VS Code or IntelliJ or a different graphical editor, then we probably interact with the terminal in one way or another. Some of us, even great and awesome developers, use the terminal like this, like I want to spend as little time in it as possible, and I think that's a shame. I think since it's part of our stack, then it can do like awesome things and we can like kind of use it to its fullest. Otherwise, terminals are everywhere. There are terminals in each desktop operating system. We use terminals in order to interact with servers. We can even run terminals on our phone. This is an extremely underutilized platform that is very powerful, and we can do lots of things with it. Personally, I also believe that terminals should be for humans. We have this Hollywood trope of the elite hacksaw sitting in their basement, writing incantations into this magical black box. I don't think this trope serves us very well. I think that if we make terminals more approachable and think about the user experience inside terminals, then we can get more people on board. And the more people we have who use this amazing platform, the more creativity we have, the more ideas, and the better the platform as a whole will be. In my products, I try to give as equal a weight to like the product side as I give to the technology. If you try out Zellij, you will find that Zellij kind of tells you how to use itself. We have a status bar on the bottom telling you all the keys that you can do, following you as you get into the different modes, and you don't need to watch any tutorials or screencasts or read like manuals. You can just hop into the app and keep using it. So now I'm going to get into the more technical side of terminals. I'm going to do it in a simplified way, like kind of a high-level view. I will simplify a lot of concepts, and some of this might like not be new to some of you, but I ask that you bear with me because we're getting into the more interesting stuff soon. I just kind of want us all to be on the same page. When we talk about the terminal, we're usually talking about the terminal emulator. The terminal emulator is an application like any other that runs on our machine. Examples of terminal emulators are Alacrity, iTerm2 if we're on the Mac, Console, GNOME Terminal. There are lots of them. This is the UI layer. The terminal is in charge of arranging text on screen, breaking lines, and managing scrollback. It has an ANSI interpreter, which interprets the ANSI escape codes that come from the shell, the control layer, and like kind of places them on screen in the right places. The shell, examples of the shell are bash, zash, or my favorite shell, fish, is the control layer. It provides us with an interface to the operating system, giving us file traversal capabilities, allowing us to fork commands, start processes, and giving us like limited scripting capabilities, such as run this command, after it's done, run this other command. If one of these two commands fails, run this third command. These are like the long incantations that I talked about the lead hacks are doing. The two of these communicate through an operating system entity known as the PTY. PTY stands for pseudo teletype. It abstracts over std-in and std-out, keeps track of the primary side of the connection, which is the terminal emulator, and its like process ID. This is sometimes called the controlling terminal, and the secondary side, which is the shell. This is a stateful connection, so it also keeps track of certain pieces of state, such as the capabilities of the terminal and the number of rows and columns. So we can, for example, imagine that we like enlarge the terminal window, and like the PTY is in charge of sending the correct signal to the shell, so that the shell knows to do stuff like re-render itself if it needs to. These two communicate between them in something that is called, like colloquially, ANSI escape codes. ANSI escape codes started as a standard at the end of the 70s by ANSI and like ECMA, if I'm not mistaken. And they have kind of been developed in a patchwork way over the years with like various additions added to them. Around the turn of the century, Xterm did a lot of work on ANSI escape codes, adding things like interacting with the clipboard or changing the terminal title. I want to look into an example of how these work because this is the infrastructure that we're building all the cool stuff on. So it's cool if we understand it a little better. Here on the left, we see a blob of ANSI. This is what we will see if, for example, we write a Rust program, ask it to invoke our default shell, take everything from std out and debug print it to screen. This is fish, my default shell. And as we walk through it, we're going to see on the bottom what we will see on the terminal. And on the right, we're seeing the state of the parser, the action that we're currently working on, the position of the cursor, and like the foreground and background colors. So we start by telling the terminal to change the char set to ASCII and to clear all the styles because we don't know what happened before us. We're moving to the beginning of the line, and then we're deleting everything on the line after us because we don't know what was there before. We're printing this clear text, moving to the next line, changing the terminal title. This is one of the new ones that I was talking about, clearing the styles, and we continue on our merry way, changing colors and rendering the prompt. I find that there are two really cool things about ANSI escape codes. The first one is that this has been a protocol that has been more or less stable since the turn of the century. That's more than 20 years for those of us counting. This is super, super stable. Even though things were added to it, then if the terminal gets something that it doesn't know, it kind of skips over this, over like the specific escape code and continues rendering everything else. If we take like a blob of ANSI escape codes that was rendered today and place it on very old hardware, 20, maybe even 30 years ago, it would mostly work. Personally, I find this amazing. The second cool thing about this is that this is a progressive rendering protocol, meaning that we are walking through the ANSI escape codes and rendering them one by one. Of course, in a normal terminal, we won't see this because it will be happening too fast. But if we like contrast this into more modern rendering solutions, such as the browser, like if inside the browser we like cut a JavaScript file in the middle, then like the website will likely crash, or that part of the website at least. This is not true to ANSI escape codes. We'll just get like half a rendered UI and like, which is not a great experience, but it allows us to treat this as a stream. We can take a stream of ANSI escape codes and pipe it into two different places, like two different terminals, for example, and then have them mirror each other. We can take the stream and pipe it into part of the screen so that we have a like a scroll going by of some commands, and we on the top right part of the screen, and on the bottom left part, we can continue working while this is happening in the background. This is kind of like how Zellij implements floating panes. Now that we know a little bit more about how a terminal emulator works, let's talk about how a terminal multiplexer works. A terminal multiplexer is the infrastructure layer of Zellij. We saw that Zellij can open various different panes, floating and tabs and everything like that. We do this by instantiating a PTY for each tab, and on the other side of the PTY, we have a shell. The shell does not know that it's connected to a terminal multiplexer. It thinks it's connected to a normal terminal. Zellij has an internal terminal emulator, essentially an ANSI parser that takes all of this ANSI, represents it in an internal state, and when it needs to, serializes it back into ANSI to like kind of do the right thing on the user's screen. So that we say like in this like diagram, for example, we go to the top left, we render shell 1, we move to like the middle of the screen, we render shell 2, any pieces of UI that we need in the middle, and the like. The upshot of this is that we get the ability to keep sessions alive regardless of a terminal emulator. If we start Zellij on a server, we can like shut down our terminal emulator, close our laptop, go home, SSH back into the server, attach to the session, and like we are continuing to work where we left off. The session stayed alive, any processes inside the session continue working. Zellij is also a terminal workspace, meaning it has extra goodies on top of all of this. Zellij has first-class command, edit, and plugin panes. If you remember, at the example in the beginning, we run the cargo tests, and when we broke them, we saw a piece of UI that tells us the exit status and allows us to do operations on this command. This is, as I mentioned, because the command was not like invoked by our shell. This is not bash that started this command. We started this command, so we know to do things, like we know information about this, and like we can react to it both in the UI and, in my opinion, more interestingly, in plugins. Zellij has first-class plugin panes, meaning like we saw a monocle, it is a pane like any other. We use the same ANSI interpreter for plugins as we use for terminals, so anything that works in a terminal will work in a plugin. We can like give a lot of information to this plugin, and we're going to get much more into this in a few slides. Zellij is also able to serialize its state into a human-readable configuration file. We call this configuration file a layout. These are files that can either be authored by hand, if I want to like specify how the panes will be arranged on screen, or we can take the existing state and say serialize it to file, take this file, adjust it as the way we want, email it to a friend, they can load it in their Zellij, and they have the same session. This is something that we also use in order to resurrect sessions. By default, Zellij does this once a minute in the background, serializing the session into cache, so that if your computer crashes, you are able to attach to this same session, and Zellij will resurrect it. It will arrange the panes in the same way. It will detect the commands that have been run in each pane. And then it will like ask you, you had a command that was running here, do you want to press enter to run it again? This is to avoid like uncomfortable things with rm-rf, or not to mention cargo publish, based on a true story. Zellij also has true multiplayer collaboration experience. If we imagine the session on the server, we can attach to it from different computers and have different users working inside the same session. I say true multiplayer because, as opposed to other multiplexers, Zellij gives each user their own colored cursor. So we can kind of have the Google Docs experience in the terminal. It's super cool to do things like collaborative coding or mob programming, I'm sorry, in this case. I've done it a few times and it's very fun. I muchly recommend it. I want to get more into Zellij layouts. So this is how I run the Zellij end-to-end tests. We see the layout file on the left and what it will create when we load it in Zellij on the right. So for end-to-end tests, what we essentially do is we compile a release executable of Zellij, we place it inside a Docker container, then we SSH into this container, send it a few commands, parse the std out with our ANSI parser, and like snapshot it to make sure things are like kind of correct. So here we have like 4 parts of this process. We have like clearing the Docker environment before, because like I don't like testing on old cache, it's not fun. We start the Docker compose, like the Docker environment. We build the Zellij executable inside the Docker volume, and then finally we run our tests. While we could, of course, do this in a single script, then like this is much more visual. We are able to like go pane by pane, press enter to run the command. Hopefully in a bigger window. I just kind of wanted the people in the back to be able to see this as well. And we will see its output like scrolling by on screen with each command. There are Zellij plugins, by the way, that do this automatically, like run this pane, when it's done, run that pane, etc. The layout file that we see on the left is written in the CUDL configuration language. In case you don't know it, CUDL is a relatively new configuration language that is very friendly and very human readable. I found it especially good for layouts because as opposed to TOML, for example, you are able to nest it. So we can have a hierarchical structure. Panes can be logical containers that contain other panes, and we can like have the Fibonacci thing of panes on screen. Here in the layout, we see the 4 panes. Each pane, like we have the main layout node, and inside we have pane. The first attribute name is the title of the pane. Like I removed it from the UI for this screenshot, again, to make it like easier to read in a presentation, but like normally we would see it rendered in the UI as well. Then we have the start suspended true, which gives us this banner of like, don't run this immediately because I don't want to run my tests before I build my executable. And then we have the command and the arguments that we pass to it. Zellij layouts can also, of course, contain plugins because we know that plugins are first-class citizens here. If we think about it, this gives us composability of plugins out of the box. We can define, I want this plugin to run here and that plugin to run there. I want them to communicate with each other. I want like to kind of do a separation of concerns. I want to instantiate this plugin with this configuration in this place, so it has a specific role with that configuration in that place. And now to the main event, our WebAssembly/WASI plugin system. WASI, in case you don't know, stands for WebAssembly Server Interface, if I'm not mistaken. What we do here is essentially we take the paradigm of the terminal multiplexer, and we say instead of using this 20th century technology of instantiating a PTY with a shell on the other side, let's place a more modern component here. And instead of the PTY, we have a WebAssembly runtime. Instead of the shell or whatever that is running on the other side, we have a WASM file. This, if we like contrast it to traditional terminal applications, it gives us easier distribution. The old maxim of compile once, run everywhere, ... that you have a Zellij runtime. This also gives us sandboxing. So WASI limits us specifically to a certain directory in our file system. If we run a plugin inside this directory, then it doesn't have access to the rest of the file system, and like we can be quiet that it doesn't do like bad things to our home directory or whatever. We also get easier development. We get composability through layouts. We get built-in UI components. Zellij has built-in UI components for plugins so that we don't need to search for terminal UI libraries in order to render UI. We can tell Zellij, render a table here, render a nested list here, and it will kind of even match the user's theme. We can, of course, use terminal UI libraries because everything that works in the terminal works inside a Zellij plugin. So if we want to, we can do that. A personal recommendation for me, if you want to go that route, is to check out Ratatouille. It's a really cool terminal UI library for Rust. I think some maintainers are sitting in the audience. And we also get an output buffer. So we saw in the ANSI escape code example that we kind of had to remember what was on the screen before us, or at least handle it. Like we had to do delete everything on this line before and things like that. So anyone who has developed for the terminal has either used a library to do this or kind of did their own diffing on their own because it's a super annoying problem. Zellij does this for us out of the box. It kind of does the diffing and renders only the relevant part that we want to screen. Plugins also get stronger capabilities. They can affect the Zellij state. They can know things like the user changed focus to a different pane. A certain pane was opened. The user moved to a different directory. Another user connected to the session. A command started running, a command finished running with this exit status, and there is a lot of stuff that plugins can both do to the whole workspace and react to the whole workspace. Zellij also gives plugins a permission system. Since many of the commands that the plugins do, they do not through the WASI side, but as APIs from Zellij, then we gate these behind a permission. So when the plugin runs, they get like it is able to request permission, and we get like a screen that says this plugin wants to access the web, run commands, access the Zellij state and affect it. Do you approve? Yes, no. Now I want to get into developing Rust plugins. So since it's a WebAssembly Rust plugin system, we can develop plugins in any language that compiles to WebAssembly, which I think these days is basically any language with some tricks. But Zellij offers an SDK for Rust plugins to make it easier, because Zellij itself is written in Rust, and Rust is my language. And that is what I want to talk about. There is currently another SDK for Go as well. Maybe there are some Go developers here. That was developed by the community. I'm very much looking forward to it having like increased adoption, and I'm happy to do anything on my side to make it happen. And I of course want SDKs for any language. I don't want the plugin language to be like a barrier of entry for developers. In the Rust plugins, like when we look at it from like this angle, then we use lifecycle methods in order to communicate with the plugin. For those of you who have written UI code before, it's kind of like a similar concept. We have the Zellij plugin trait that we export from the SDK. The SDK is called Zellij tile, and it's a crate like any other. You can install it from crates.io. And the Zellij plugin trait exposes 3 lifecycle methods. The load method that happens when the plugin is instantiated and gives us user configuration for this plugin. Plugins can define their own configuration. It's an arbitrary dictionary of string to string. You can do with it whatever you want. You can ignore it and not use it however you like. We can expose things like different roles for the plugin. Like we said, this plugin here does one thing, this plugin there does another thing. And we can, of course, expose things like the background color. There is a plugin that does this, that the user can define a background color for their status bar. It's a cool plugin, ZJ Status, check it out. In the load function, we should do 2 things, essentially. We should request the permission that we want, because while we can do that in different places, I think it's a better experience to request it on plugin load, rather than like when in the middle of the work, like it pops out at us, this plugin request permission. I don't like it when the browser does that, and I think it's better to just do it at the beginning. The second thing that we should do is to subscribe to the events that are interesting for us inside the plugin. Events are Zellij entities such as key press, focus change, and all the things that the API can do. These events are sent to us through the update method. When they happen, Zellij calls the update method, gives us the event, and we can react to it. We can run plugin commands, which are traditional commands like that can run on the host machine if we have permission for that, and also like things that affect the Zellij state, opening panes, changing the way they are, like running commands, lots of stuff. If the update function returns true, then Zellij knows that the plugin wants to be rendered. So it calls the render function, telling the plugin its current rows and columns, because these things can of course change. The plugin can we can make it smaller, make it bigger, move its location. And then inside the render function, we basically do the same as we would do if rendering in traditional terminal applications. We throw ANSI codes into std out, and they are parsed by Zellij and appear on screen. How does it work under the hood? In stable WebAssembly, we have an issue that we can't really transfer complex data structures from the host machine, Zellij in our case, to the guest machine, the plugin. When I say complex data structures, I mean even a string. We can parse, like we can send integers, and that's basically it. So not good because of 2 reasons. First, we want to transfer the application state and business logic, which is more than numbers. And the second, because we want to render, we want to pass ANSI escape codes. So we solve this by serializing all of this on std in and std out, which are pipes that we get from WASI, the server interface, as part of the file system. And like we're in terminal land, this is like pretty common. That's how we do things. So like it's not new for us. We send the business logic, let's look at the example here, the tab info, by serializing it to protocol buffers. Protocol buffers, in case you don't know, are like a protocol developed by Google, if I'm not mistaken. And they first have the benefit that they can be serialized and like interpreted essentially by any language, which is good for us for like our various plugin SDKs, and also that they are progressive, meaning that if we take this tab info, for example, we have the position, the name, and whether it's active, whether it has a user focused on it or not, and we can add stuff to it later. If we did this with JSON, for example, then we wouldn't be able to add stuff because we, like plugins compiled for an old Zellij version would crash. They would not know how to deserialize this. So here we are able to add like a number 4, 5, 6, however we want. If we want to add logic to the tab info trait, old plugins will simply ignore it. Then the second problem is, I already mentioned before how we solve it. We, like in the render function, we pipe like ANSI escape codes into std out. It's a stream. We are able to do it. It's not a problem. And we interpret them with the same ANSI interpreter as we use for terminals. Zellij plugins also have access to UI elements, and the UI elements are cross-language. That means that a ribbon, for example, the first UI element here will look the same whether the plugin was written in Rust or in Go. It will also fit the user's theme. It's easy to get off the ground with them. The SDK like kind of does this for you. Serializes them into std out, and Zellij does the right thing. And of course, they fit the user's theme, they fit the behavior that the user configured in the application, and allows us to get like a consistent dashboard experience across plugins. This is an example from the Rust SDK. On the left, we have the Rust code. On the top right, we have how it would be rendered into the application. And on the bottom right, we have how it would be serialized to std out. This is our UI component protocol that we'll get into more in the next slide. Here in the Rust code, we see that we instantiate a new table, and in the builder pattern, we add rows to it continuously until we're done. We can either like add a row with text, and the table will change the styling according to what is like the classic behavior of the table, or we can style indices inside the table to different colors. We can define them as selected or not selected as we wish. Then finally, we print the table on the end, and it appears in like std out and the user's pane. The way we kind of have to do this, we can't really talk directly to the Zellij API and tell it like render a UI component here, because the render function exports ANSI code. Like at this time, Zellij expects to send ANSI code, expects to get ANSI code and to interpret it. It can't like read other stuff from std out and interpret it differently. So in order to solve this problem, I basically made up a protocol. I used a private ANSI range, and when Zellij gets it, it knows that it needs to pre-process it and turn it into different traditional ANSI codes that will be understood by the user's terminal. Here we see at the beginning the start, like the escape character PZ, the start of the private range, then the name of the component. its coordinates. Optionally, we can tell it XY coordinates within the pane. We can limit its width and its height, so we don't have to deal with like line truncating on our own. Zellij even understands character width, so we don't need to deal with that super huge headache. And later, we see like the X, which tells us that this component is selected. Notice that it doesn't say anything about the styling. It's just is selected, do what you think is right. And then we get the colored indices, 3 types of indices, which are indices into the text that we will see on screen, the foobar baz that we see on the top right. And here again, no mention of color, no mention of anything, just like do what you want with these indices. And then later we see the UTF-8 encoded content, which is foo space bar space baz. Finally, I want to go into like 2 plugins to like give us an idea of what we can do with this infrastructure. I'm going to start with what is currently my favorite plugin, WeatherPal. I finished writing it on the way here. I have this problem that I like sometimes going on bike rides in the middle of the workday to help arrange my thoughts, and I don't so much like it when it rains on me. But if I'm in the context of the terminal, opening the browser and going to like some weather service is like changes my context, throws all the notifications on me, and I really don't want to go there. So instead, I use this, which is a Zellij plugin that parses my location from the system time zone. Like geolocates it, or geocodes it rather, with an API to get the longitude and latitude, and then goes to another weather API to get the weather information that we display here. The APIs that I use, by the way, are from OpenMeteo, which gives us like a free like a free weather and geocoding API without registering or giving a key or anything. Super awesome, props to them. Looking further at the plugin, we start with the load function. Here in the load function, we do the 2 things that like we know we need to do in a load function, which is requesting permission to first read the application state so that we can know when the user is focused on us and presses enter because they want to reload the plugin. Then we are able to run commands, or we ask rather to run commands so that we can get the user's time zone, and web access so that we can access the APIs. We subscribe to the relevant event key, and then web request result and run command result. Stable WebAssembly at this time is single-threaded, so even if we could do a web request from the plugin, we probably don't want to because the UI will get stuck until we're finished, and it's not a super good experience. So we do this with an API from Zellij, and when it's done, Zellij sends us an event back with like all the data and the status. When we start the plugin, we'll get this sort of screen that will like tell us about the permissions that the plugin is asking for. I tried to make this as straightforward, easy, and non-obtuse as possible so that the user can give informed consent and really understand what the plugin wants to do on their machine. When the user says yes or no, we get an event, which is permission request result, so that we know what happened and that we can continue and render our UI. Now we look at part of the update function for this plugin. And specifically, I want to look into the 2 events that I mentioned, the key event and the run command result event. Here in the key event, if we get the \n key, also known as enter, we change our state to fetching data. This is so that we can render a fetching data to the user. This is, by the way, a good UX tip. Anything that the user does in your application, the UI needs to react, whether you expected them to do this or not. Like, give a reaction. This makes the app seem responsive. Then in the end, we run the command, which is basically bash -c and this get time zone incantation. And we give it a context. A context is an arbitrary dictionary of string to string that we can use for our own convenience. Zellij doesn't do anything with it. It doesn't read it. It just returns it as is on the result. Here we use it in order to identify the commands, to say this was a time zone command request. So that like if we get another command, because later we added a command, then like we won't start the whole weather fetching thing. We can also use it for things like request ID, for like putting a timestamp there to measure how long the command took, whatever we need. And then we change should render to true, because we remember that if the update function returns true, then we need to call the render function, and the Zellij will do it for us. Then the second event, the run command result, we get here the exit code that we can react to, whether the command succeeded or failed. We get like the bytes of the std out and the std error, and of course our context. And then we parse it, place it in our time zone, and make the geocode request with a time zone, but that's like out of scope for here. And as we return the should render, we have the render function. Here we create the table. We loop through the weather data that we got, like one hour at a time. And then we create, like we add to the table. It's a builder pattern, so we have to like kind of run over the table every time because it's inside a loop. And then like we do the text new with the various data. We color it, style it as we want, so it appears amazing and beautiful as it was. And eventually we print the table. And finally, I have a bit of time, so I want to take a quick look at Monocle. And this is the plugin we remember that we saw at the beginning that gives us the fuzzy find of file names and contents. And the interesting thing that I want to see here is to find out how we go around the WebAssembly limitation of it being single-threaded and do like async stuff or background tasks, if you want to call it, probably more accurate. So the problem that we have is that when this plugin starts, we need to scan our folder. This is of course a blocking operation, and for large folders it can take a non-trivial amount of time, and during this time we want to show the user like a loading animation so that like we're responsive, they know something is happening, and they don't just spam enter what is going on, why is this plugin not working. So we do this by instantiating two workers. We do this with the Zellij worker trait that we're going to look at in the next slide. And here in the load function, we send a message to both of them, post message to worker. We send it the worker name. The worker name is a namespace that we control. Here we have file name search and file content search because one of them is faster. We send it a message, again, arbitrary string to arbitrary string payload. Then we forget about it. We set ourselves to loading and tell Zellij to wake us up in half a second with like an event so that we can progress the loading animation. The Zellij worker trait is essentially one method, onMessage, which is what happens when we get our message. I chose to serialize the message into JSON, but like we can use whatever. And then we do the scan HD, which is a blocking call. For the scanning, by the way, we use the ignore crate. I think it's also used by ripgrep. It's a pretty cool crate that gives us like the walk deer thing, but also respects our get ignore and doesn't go into hidden files. And so it's both much more relevant and much faster. Then once we are done, we post a message to the plugin, which the plugin will get as an event, telling it we're done loading, you can remove the loading animation, and the user can start sending us stuff. In the future, like continuing to work on Zellij, I plan to work on a Windows version. Zellij right now is unfortunately only available on Linux and Mac. I think it's a pity. I think we can give Windows users like a really good terminal experience. I also want to create a web client so that from within Zellij session, we can share this session on the web. It will start a web server, and we can open a browser tab and be inside our terminal. I also want to create a service that we can optionally access from within Zellij that does this session sharing for us. So instead of like starting our own server and kind of doing the port forwarding thing and everything that is required, we'll get a Zellij dev or whatever URL. We can send this to a friend. They can securely connect to it, and they are in our session. Maybe the service will even keep the session alive. The service can also allow us to resurrect sessions so that we can save the current Zellij state instead of to our cache, then to the server, and people can and then we can resurrect the session from different machines, do whatever. I also hope to have a plugin marketplace. Since we publicized the plugins a few months ago, they're becoming more and more popular. People are writing more and more plugins, and we get more and more questions on our Discord of where do I find plugins, what cool plugins are there. I want this to also be accessible from within Zellij so that we can search for plugins, and those people who want can even charge money for plugins if they want to. And in this venue, I work on Zellij full-time and have no other income. I love Zellij to death and think it is really cool, and it is a very cool infrastructure that we can build a lot of stuff on in the future. If you want to help me do things like pay rent and go to the supermarket, which I like to do sometimes, then I would be happy if you consider sponsoring me on GitHub. And now I will take your questions.
Yeah, is there any intention to make the permission system more granular, like only access specific URLs or file system directories?
I didn't think about that, but totally, we can have sub permissions that they can request to access a specific URL, and yeah, that's a good idea.
Okay. Sorry.
Thank you so much for Zellij. I really enjoy using it. It's been so nice. And I was curious if there are any plugins that you would dream of someone out there creating, like any plugins that you would like to see be brought into existence.
So my idea with plugins is to essentially outsource the product side of Zellij to other developers, so that people don't want to oh, I want this feature and that feature, and yeah. So I'm not so much thinking of specific ideas, but rather of capabilities. So I have this small plugin, for example, multitask, which is does the whole mini CI thing, open this pane and that pane. I think it could be super cool to hook it up to whatever people need. People suggested hooking it up to a proc file of Heroku to interpret the file and do it on screen, to hook it up to Docker Compose, to Dockerfile. I think someone is writing a Kubernetes plugin and such. But these are just ideas. The best ideas will come from plugin authors, not from me. I just want to allow them to do it. So intentionally, I try not to direct to specific directions.
Questions there? We've now seen two plugins, two ways to do plugins for Rust with the, what was the name of the first talk about? Stubby, yeah. And now the WebAssembly way. Do you know what the overhead of the WebAssembly plugin way to do it is?
Do you mean performance-wise?
Yeah.
There is a performance overhead for sure, mostly because we have to serialize stuff, everything through the WebAssembly boundary. In my opinion, this is meaningless to terminals. I think when we talk about terminal performance, it is most of the terminal applications that we have a refresh rate of 1 second, and they don't do it well. You still see them kind of deleting the whole screen and re-rendering it and such. And like, I don't think this is a problem we have, at least not right now. I hope to have things like a streaming interface to allow us to like stream things to plugin and not just have like distinct events and things like that, but like on like and then performance will kind of be a question, and we'll have to think about how to do that, and that for sure. But right now it's not a problem we have.
Okay, thank you.
Sure.
There was someone there.
So first a joke question and then an open-ended question. The joke is, when will we have a graphical web browser running Zellij? And the open-ended question is, okay, I was considering using Zellij. I'm switching to that. I'm sort of resisting because workflows are tricky. And I know that when eventually I will commit to Zellij, I will have to change my workflows, and I don't have just the time to stop doing things to change the workflow. But that said, one thing that is sort of making me resist the thing is I use a tiling window manager. Mm. And part of my workflow is based on arranging the tiles properly. And I think that Zellij does something similar inside the terminal. And I sort of fear that at some point I will have my workflow fractioned in things that can stand in a tiling window manager tile and things that can stand in a terminal tile, and moving from one to the other, arranging them. And I have two big monitors and moving things between the monitors. Have you ever thought about integrating Zellij with that tiling window manager so that people can have a unified experience desktop-wise? This is the open-ended question. Sorry if it's long, this is crazy, but this is the thought.
So I'll start with the first question, and I'll say that I definitely want to see a graphical browser inside Zellij, and specifically like any graphical application. Zellij, I didn't have time to get into it, but Zellij supports Sixel, which is kind of an old graphical protocol for the terminal, developed in the 90s, if you can believe it. But it's not very performant. There are several other protocols like kind of going around with various degrees of popularity. There's also one being developed by the Terminal Working Group, which I am personally counting on. Once we have that, then like for sure I will want to integrate it, and I will want to like make all the things work with it. But like this is not only dependent on me, of course. And as for the second question, I use a tiling window manager. I use i3. I find myself like in the tiling window manager mostly like kind of using it for tabs and maybe a little bit to split the screen, because most of the things that I want to do is split terminals. Like graphical applications, putting Firefox and half a screen, to me it doesn't look very well. And I think like this need for me comes mostly from terminals. That being said, integrating the movement of focus between tiling windows and terminals sounds like a really cool plugin.
Okay, I think we don't have any more time for questions because we have to prepare the next talk. So thank you, Aram.
Thank you.